Hello, am I audible? Hello.
Yes, sir, audible.
Yeah, maybe you can take this problem, then start plotting the bode plot. So it is 100s divided by 1 plus s, 1 plus 0.01 s into 1 plus 0.02 s and 1 plus 0.1 s. So we will start the uh, can we find out what is magnitude at the origin? Who is there with me now? Sindhushi, can you unmute yourself? Hello, Sindhushi.
Yes, sir.
Yeah, let us try to find out what is magnitude at the origin. When I say origin with omega is equal to 0.1 radian per second, so that will be 20 log k plus of 20 log of omega. So why it is plus? Because you have a 0 at the origin, open loop 0 at the origin, correct? So will this now become 20 log 100 plus of 20 log 0.1? So I just want to know from you people, okay, do you have any doubt in, okay, how do we write it and what is the significance of this? So is it 40 minus of 20, is it not 20 dB? Does anybody has any doubt, okay, why I'm writing it as plus for a 0 and why it is negative for a pole? Shall I explain it again or what? So this is magnitude at the origin. Sindhushri, how about you? Do you have clarity in, okay, why it is so? Hello. I just want the response.
Yes, sir.
What is, sir? Are you thorough with that? Okay, do you have any doubts? Hello. I want someone who can respond to be unmuted. This is online class. I want to know your mood, no? Okay, how are you able to get it? Okay, what I'm writing. Hello.
Yes, understood.
Now, is there anyone who is having doubt? Okay, why it is 20 log k plus 20 log omega for 0 at the origin? Ayush, can you tell me why it is plus? How do you justify plus is correct?
Sir, because origin is at 0, sir.
Okay, if origin is, no, what origin is it 0? It's not origin is 0, there is a 0 at the origin. There is a 0 of the transfer function at the origin. If it is so, why it should be plus and that magnitude at origin? What is actually significance of this magnitude at origin? Because when we actually started this one now, so when we started this bode plot, did we start like this? So did you write it for each and individual term?
Yes.
So when we started, so we started from a very small value and then went like this. So for 20 it was a constant value, and for 1 over 1 plus 0.1 s it is still 10, it is 0 dB, and then it comes down, and then for this one till 50 it is 0 dB, and then it is coming down at 20 dB per decade, correct?
Yes, sir.
Now the question is, so if you want to plot the resultant, you need to have all the three, correct? You want to have all the three, and then of course this is how we added the magnitude. Now how it came as 26? It came as 26. It is 26 plus 0 plus 0. Is it not 26 dB here?
Yes, sir.
So is the magnitude continues to be 26 till 1 radian per second?
Yes, sir.
And then afterwards you have a slope.
Yes, sir. Till
So
10.
suppose if I want to write what is magnitude the origin, can I write it as 20 log k plus or minus 20 log omega or omega at the origin. So
Yes,
in
sir.
this case, this 20 log, okay, let me just write as 20 into n. So what is this n here?
N is um,
What is
number
n?
of zeros.
Where? That's very important. What is n here? Can anybody? What is this n? So unless we are thorough with that, okay, it's difficult. Okay, otherwise you people
Number
will.
of zero and open loops, sir.
Number of poles or zeros at the origin, not simply open loop. How many number of zeros or poles are at the origin in your open loop transfer function? What is okay? Are there any zero or pole at the origin for this transfer function? Do you
No,
have
sir.
a S term here? Do you have a S term here? You don't have that. Correct.
Yes, sir.
Then what is the value of n?
So 0.
0. When it is 0, you don't have this term at all. So do you have 20 log k?
Yes, sir.
So what is
20
k
log
here?
20.
20. So 20 log 20 is 26. So that's why magnitude of the origin is 26.
Yes, sir.
So with this equation itself, without having the individual plots, you can start plotting the graph. Correct?
Yes, sir.
Suppose if I plot the individual plots, okay, what is for 100? What is for 100? Suppose if it is 0.1 radian per second, for 100, what is the plot?
It will start from 20 and it will end at
Oh,
1.
bhaiya, this is 100, no? If it is 100, 20 log 100 is, no. If it is only for 100, I'm asking you the individual plot. Let us come to this later. So what is this individual plot of 100? I want you
100.
people to understand why I'm writing it so. How many of you understood, okay, why it is 20 log k plus or minus 20 into, let me write it as 20 into n. Okay, let me just see in the chat box how many of you know what it is. How many of you are confident you know it? Just say yes, no. No, be frank. If you don't know, let me know, okay, what is, whether you know it or not. So why that is important? Unless you don't have this one, then you cannot start. Yashaswini, tell me why. What is the 20 log k plus or minus 20 n log omega org?
Sir, plus or minus because it will depend upon whether the origin is at 0 or
Oh,
poles there.
madam, this is
So,
not origin is at 0. 0 is at origin. Please make
yes,
this
sir,
English
0 is
correction.
at origin or pole.
Come again. No, why it is plus if it is a 0 at the origin? That's my question. Why you are writing it as plus? Why it is minus for a pole at the origin? That's the question. Since I said, okay, plus you take 0, for 0 you take plus, and negative you take it for pole, that is okay. You can just follow me and then do it. But why it is so? Hello. Hello. Now, okay, how many of you are now saying yes or no? Say at least no. I don't know, sir. Please explain it again. That is fine. No, it is. Don't simply go by some equation. You just substitute and then get a procedural thing. So what the term you have? You have 100 divided by 1 plus s, 1 plus 0.1 s, if I'm correct. Yes, and then 1 plus 0.02 s and 1 plus 0.01 s. Am I correct? One of you unmute. Of course, into s is there. DFS
Yes,
into
sir.
HFS. Okay. Can we write the individual plots?
Yes, sir.
So this is 0 dB. What is individual plot for just 100? 20 log 100. Is it not 40 dB?
Yes, sir.
For S term, this is for 100. For S term, what is the plot? This is omega. Let us take it as 0.1 radian per second. Now we are trying to understand conceptually what we are trying to do. Otherwise, procedurally, just close your eyes and then keep doing it. You'll get the same answer. I don't want my students to do it like that. So for S term, what is the plot? Suppose if you just go back and see what is for S 1 over S. What did we wrote? Can somebody?
1 over 20.
See here. For S, what was the term? See here. For 1 over S, is it not a straight lane having a slope of minus 20 dB per decade passing through 0 dB at 1 radian per second?
Yes, sir.
How about for S now? Is it not a plus 20 dB per decade line passing through 0 dB at 1 radian per second?
Yes, sir.
So, can I write it? Suppose if it is 0.1, for S, what is the initial magnitude?
Minus 40.
See here. Okay, let me write it so. For S, what is this? So, is it a straight line with plus 20 dB per decade passing through 0 dB at 1 radian per second? Am I correct?
Yes, sir. Yes,
Shall
sir.
I take it as 1 radian per second here?
Yes, sir.
Shall I draw a line now? This is what?
Yes, sir.
Plus 20 dB per decade. This is positive slope, no?
Yes, sir.
If this is 1, if it is 0.1, at 0.1 what will be the magnitude? The slope is 20 dB per decade. You are coming down by 10 times. What is the magnitude here? Here it is 0 dB. If it is 0 dB here, then what is this here?
20.
Plus or minus?
Minus.
Is it not minus 20 dB?
Yes, sir.
Now, shall I now write this is 1 radian per second and this is minus 20?
Yes, sir.
How about this term? Is it till here and then goes like this?
Yes, sir.
How about this? Suppose if I write it simultaneously, is it this and this?
Yes, sir.
This is 1, this is 10. How about this? Is it not till 50 it is like this and then coming down?
Yes, sir.
How about this? How about this?
100.
Is it not 0 dB till 100 and then comes down at
Yes, sir.
so and so?
Yes,
So
sir.
all
100.
of them are having what? Minus 20, minus 20, minus 20 per decade.
Minus 20.
So what is the magnitude at the origin now? At the origin. Are these terms contributing 0 dB? Nothing. There is no contribution by them at 0.1 radian per second.
Yes, sir.
Then the contribution is by whom? It is by this term and this term at
Yes.
0.1 radian
Yes,
per
sir.
second. So what is the contribution of this? Is it not 20 log 100?
Yes, sir.
What is the contribution of this S term now? Is it not plus 20 log? Okay, actually is it not minus 20 dB?
Yes, sir.
So if I write it so, is it not 40? What is the magnitude here? Suppose if we just add the magnitudes. What is the magnitude here? 40 plus of minus 20.
Yes, sir.
What is the magnitude?
20.
20 dB. Suppose if I do this, 20 log of k plus 20 log of 0.1 radian per second. Am I not getting 20 dB only?
Yes, sir.
Suppose if I put it as minus, what will happen? It will become 60 dB.
Yes, sir.
So that will be true if you have this 1 over S term. If it is 1 over S term, is it not 20 dB?
Yes, sir.
Then what is the initial magnitude? Is it not 40 plus 20, 60?
Yes, sir.
So then is that 60 is correct? If it is a pole, should I have to have it as negative?
Yes, sir.
Because a 0 will always have lesser amplitude at 0.1 radian per second. You just make it as plus here because 20 log of 0.1 will be a negative quantity.
Yes, sir.
Because this will become 20 log k is 40. Is it not minus 20? So will it not coming out to be 20 dB here?
Yes, sir.
So does this represent this?
Yes, sir.
Does this entire thing represent this one?
Yes, sir.
What is this here? This is a 0 at the origin.
Yes, sir.
If you have a square here, then this becomes 40 times 40 log 0.1.
Yes, sir.
Because
Okay.
if it is for square, it will be minus 40 here. Correct?
Yes, sir.
Okay. So I hope now it is clear. So what
Yes,
is
sir.
magnitude at the origin now? Is it not now 20 dB?
20. Yes, sir.
Provided this is 0.1 radian per second. If it is 0.01,
Yes.
then it is 0 dB, because 0.20 log of 0.01 will become minus 40. This is 40, 40, 40 will go up and you'll end up with 0 dB. If it is
Yes, sir.
0.01. Correct?
Yes, sir.
I don't know whether I'm just making you people to think too much. This is minimum thinking, I say. There is nothing great in this, but you should apply your mind. I don't know, okay, when you're sitting there, I don't know the ambience, how you're there. GFS into HFS is equal to 100 into S. I'm just repeating. 1 plus S, 1 plus 0.1 S, 1 plus 0.02 S. I'm just putting it in increasing order of cutoff frequency, 0.01 S. So magnitude at the origin is 20 log 100 plus 20 log 0.1 radian per second. Correct? Is it not 20 dB? Shall we write the table? Is this clear now? Hello.
Yes, sir.
Okay. Can you start telling the table terms? Who is there with me? Start telling the terms. Hello. Ayush, can you tell me the terms?
Yes, sir. 100S.
Okay.
Slope is
20.
plus 20.
Next.
Plus 20. S plus 1 by S plus 1. Slope is minus 20 and 0.
Okay, then
1 by 1 plus 0.1 S. 10 minus 20 and then minus 20. 1 by 1 plus 0.01 S. 100. Sorry, 50 and minus 20 and minus 40.
correct.
Minus 20, minus 60.
Done. How many of you could able to get the Semilog sheets? Now I will just make sure that today, because now the market will be open till 5 o'clock. I want you people to get it and then submit all the problems whatever we have done till date. I want you to submit it immediately. That is before 8 o'clock today. I can't just wait you people to relax too much. Shall we do it now?
Yes, sir.
Okay, what is the initial magnitude? You have 20. Shall I start with 20 dB here at the top? Because magnitude origin is 20. See, the initial slope is 20 dB per decade. It actually goes up.
So we should take a little bit down.
So let us put it down so that slope goes up. Suppose if you take this itself as 20, you cannot just go up there because you don't have the markings. So let us take it as this as 20 dB. This is 0, minus 20, minus 40, minus 60. This is 40, 60. Correct? And then let us take this as 0.1. This as 1, this as 10, this as 100, 1k, 10k. Done?
Yes, sir.
Okay, then shall we start now? What is the initial magnitude? Is it not 20 dB?
Plus 20. Yes.
So is the slope plus 20 per decade? Is the slope plus
Yes,
20
sir.
per
Plus
decade?
20 till
So you
1.
go up by 20. This is 1 decade. So is this 1? Shall I join this and this? I'm there. Is there at least anyone having the Semilog sheet? Having the curiosity of plotting
Yes,
it?
sir. I'm having.
Okay, anybody else? How many of you are having it? Let me just know the chat box. Does anybody has it? Okay, then what is the slope? Next slope is 0. Till where?
Yes, sir.
10. Till where? 10. So shall I draw a straight line with 0 dB slope, 0 dB per decade slope till 10? This is 10. This is 10.
Yes. Yes, sir.
And then
Minus 20 till 50.
minus 10 till 20. So you come down by 20 dB, go by 1 decade, but you stop it at 50. Correct?
Sir, it's not 50. I think it's 100.
Oh no, yeah, it's 50 now. Point not to.
Yes, sir, 50. But you were taking
I
100.
have to take the point here. This is 1 decade. I had to take this slope is 20 dB per decade. You don't take it at 50. Come down by 20 dB, go to 1 decade. Forget about the cutoff frequency. This is a mistake
Yeah.
what you people will do. Come down by 20 dB, go by 1 decade. That will constitute a slope of minus 20 dB. Till where? Till 50.
Yes, sir.
Getting the point?
Yes, sir.
This is 20 dB down, 20 dB down, 1 decade. So this will be 20 dB
Minus
per
20.
decade, minus 20 per decade. Till where? You stop it at 5. So let me just draw a dotted line.
Okay. That's fine.
You have to draw, you have to take this as 100 as your reference. I have written the dotted line only, solid line till only 5. So I will just
Yes,
make this solid only till 5. Correct? So
yes,
then
sir.
from here, sorry, 5 is here.
Minus 40 till
So 5 is still here. So from here, come down by 40 dB. So this is 20, this is another 20, correct? And go by 1 decade. 1 decade is here, correct?
Yes, sir.
So now this is the slope
We should stop at
till
100.
100 only. Sorry, I could not get a scale. Forgot. Stop it at 100. Correct? You can say I'm stopping at 100. So this is 50 radian per second. This is 100 radian per second. Okay?
Yes, sir.
Now from here, so what is the slope here?
So plus 20, 0,
0 dB per decade. This is now
plus minus 20 per decade. Minus 40.
it should be minus 60 now. Correct?
Yes, minus
So
60.
I'm actually 2 divisions above. This is 20, 40, 60, 1 decade. Correct?
Yes, sir.
So now I will join this and this. Is it not minus 60
60
dB
dB.
per decade? There is no end for getting into my class unless you practice 1 or 2 problems. It looks very easy, and it is easy also, so nothing to worry. Correct? Is this omega GC? As
Yes,
per
sir.
this, can somebody read this? This is 100. This is 100. What can be this value approximately? Each division corresponds to, it's like 110, 120, 130.
So it's near about 160.
160. Am I there? This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, this is 160 radian per second. Correct?
Yes, sir.
Is there anybody plotting simultaneously along with me? Are you Shari plotting?
No, sir.
Yes, sir.
Yeah.
Just note.
Can somebody able to get it 160 radian per second? Of course, even this may not be perfect. Maybe I might have missed out some points. Let us find theoretically what is omega gc. Can we find out? Before that, let us also find an expression for phi, the phase. Is it not 90 degree minus tan inverse of? So is there any doubt about why it is 90 degree for S? Hello. These smaller doubts. Hello. Is this one okay? Why it is 90 degree for S angle? For a open loop 0 at the origin, why the phase angle is plus 90 degree? If I ask you a question, how do you justify? Hello. 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 Suppose if it is a S term replacing S by j omega, this is 0 okay, j omega, is it not 0 plus j omega? The phase angle of it is okay, it's like okay, a plus j beta, a is equal to a plus jb, a is equal to 0, b is equal to omega. So what are the angle here? Is it tan inverse of b by a, that is imaginary coefficient by real coefficient? It is tan inverse of omega by 0. So tan inverse of infinity is 90 degree. Since it is positive angle, it is plus. Correct? Hello.
Hello. Hello.
Hello.
Yes, sir.
Okay. Can we find what is omega PC here? What is omega PC?
Yes, sir.
It is that value of omega where phase is minus 180 degree.
Minus 180 degree.
Can you do that?
Yes, sir.
Is it minus 180 alpha equals 90 minus tan inverse of tan inverse of alpha a minus tan inverse of 0.1 alpha a minus tan inverse of 0.02 alpha a minus tan inverse of 0.01 alpha a. Shift cal.
It is 81.
Okay, let me just see. I'm just waiting for answer. It is 81 radian per second. 81.56. Correct?
Yes, sir.
So it is 81.56 is omega PC. Ayush, you just have the same equation with you. So let us
Yes, sir.
don't discard that. Let us find what is omega GC. So is omega GC, is it not equal to G of j omega and h of j omega magnitude is equal to 1, where omega is equal to omega GC? Am I correct? is it not then 100 into omega is equal to what is that, under root of 1 plus omega square into under root of 1 plus 0.1 omega whole square into under root of 1 plus 0.01 omega whole square into under root of 1 plus 0.02 omega whole square. Am I correct? These are all omega
sir.
1s. Omega 1 corresponds to, we are actually supposed to find what is omega 1 if this is equal. Shall we do that? So 100 alpha A alpha equals open the parenthesis, okay, 1 plus alpha A square close into, okay, under root of 1 plus 0.1 alpha A whole square. Am I closing all of them? Okay, into 1 plus 0.02 alpha A whole square into the root of 1 plus 0.01 alpha A square. I think I'm done. Shift cal. If there are no errors, I'll get omega GC. Graphically, how much we got? It was 160, no?
160.
Is there? Why it is coming as okay. This is also a possible value. It is showing that omega GC is 0.01 radian per second. This is one of the value. This is one of the valid value. Correct? Why it is one of the valid value? See here. Can you see this? So are we looking for where it is crossing omega GC, where it is crossing 0 dB?
Yes, sir.
So we are actually finding this. What calculator is showing me is, it is actually showing me a value which is prior to this. Suppose if you just go it back, this is 0.1. If it is 0.01, what is the magnitude? Is it not crossing 0 dB?
Yes.
So whatever that is shown here is perfect. Why it is correct? It is correct
because when we extend the line, it will also intersect at 0 dB.
It will also intersect at omega is equal to 0.01 radian per second. It's not omega 0. It is 0 dB at omega is equal to 0.01. That's what is this.
Yes.
Correct? This is 0.1, no? 0.1.
Yes, sir.
At 0.01, it will again intersect. So you are looking at this point. You are looking at this point. Am I correct?
Yes, sir.
Okay. What shall I do now? So how do we find out that? So what I'll do now is, I'll just go back to this equation. I'll not divide it by. I will just make it, okay, I'll not make it alpha equals, I will make it simply divided by. See, divided by cal, if I make it 150, can you see this is the value? It is such a huge
85
value.
point.
It's okay, 85, so on, so it is showing. Okay, then cal, okay, 160. I'm just going wrong somewhere here. Is my equation went wrong anywhere? Because I have to get it as 1 now. Correct? If this is correct, I have to get it at 1. So this ratio should be 1. Getting me?
Yes, sir.
Okay, I don't know where I went wrong. Just ensure that this is 100A. That's what you have, 100A divided by so also. Maybe some parenthesis issue may be there. Otherwise, this is okay. So what we'll do now is, let me try to find out at omega. What is omega? How much is omega PC? Is it
Omega P is
86?
81.56.
81 at 81.56. What is this 80 here? This is 80, no? 100,
Yes, sir.
90, 80. So at 80, what is the magnitude? Is the magnitude is equal to somewhere here?
Yes, sir.
This is the magnitude. Is that magnitude is almost 18 dB?
Yes, sir.
Correct. What is this 18 dB corresponds to? So does this 18 dB actually corresponds to magnitude of g of j omega h of j omega at omega is equal to omega pc? Is it not 18 dB now? Correct.
Yes, sir.
Then what is gain margin? Is it not minus of the magnitude at g of j omega h of j
Minus.
omega at omega is equal to omega pc? Is it not minus of 18? Is it not minus 18 dB?
Yes, sir.
So gain margin is negative. Gain margin is negative. How about phase margin? How about phase margin? How do you find phase margin? Is phase margin is equal to 180
plus
degree plus phi at omega is equal to
phi.
omega gc.
Yes.
Is it not 180 plus you have this equation, no? You have this equation.
Yes, sir.
In this substitute, you don't do that shift cal twice. Just say cal, don't equate to minus 180. Take out that equal to minus 180.
Yes,
Just
sir.
simply press cal and substitute that variable as 160 because that is 160 here. This is 160. How much is phase? Has to be more than minus 180.
It is 2.7.
Huh? 2.7.
So it's 2.74.
Hey, come on. Oh, come on. This is 90. How come it is 2.7? Take out that 90. Okay, 180 also. 90 minus tan inverse of alpha a minus tan inverse of 0.1 alpha a minus tan inverse of 0.01 alpha a minus tan inverse of 0.02 alpha a cal 160. Is it not minus 216 degree? See here? Is it not now minus 36.7 degrees? It is minus 216, no? Is anybody seconding my answer?
This is maybe some errors.
Yeah. So phase margin is minus 36.7 degrees. Gain margin is minus 18 dB. System is unstable. How to make the system stable? How to make the system stable? What is minus 18 dB actually?
So we need to
Yeah, tell me. So this is actually minus 18 dB is equal to. What is gain margin of minus 18 dB means? How do I make this system stable? Somebody?
so it should be close to 1 dB, sir.
How do you make it? Now you have a system, you have this system, and gain margin is coming out to be minus 18 dB and its value is 0.125. 0.125. What does this means? Okay, with this K as 100, you have a minus 18 dB gain margin. System is already unstable. How do you
And by
make it?
reducing gain,
By how much?
Greater than 18 times, sir.
Not 18 times, 18 dB this is. This is crucial. You have with a gain of K is equal to 100, you have a gain margin of 18 dB. Meaning that system is unstable. How do you make the system at least oscillatory? So can you see this minus 18 dB corresponds to 0.125? Correct? Hello. If the existing gain of 100, if it is multiplied by 0.125, you'll get it as 12.5. If the gain instead of 100, if it becomes 12.5, system is oscillatory. Correct?
Yes, at just the middle.
How do you make it stable? The gain has to be less than 12.5, then only system is stable. How do you got to know this 12.5? Because that was your gain margin at 100. When K was 100, you had a gain margin of minus 18 dB. If the gain becomes 12.5, then what is gain margin? It is 0 dB.
Yes, so 0 dB.
When it becomes 0 dB, system is oscillatory. How do you make it this positive? Make sure that this is less than 12.5. A gain of 10, 8, 4 will make the system as stable, because then the gain margin becomes positive. That you can verify also. Okay.
Yes, sir.
I hope you people can able to understand what I mean to say here. You have a gain margin of 18 dB with the existing gain of 100. So the gain margin of minus 18 dB means the existing gain has to be reduced at least 18 dBs. So what do you mean by 18 dB? So this 100 actually corresponds to 40 dB. That 40 dB has to become minus the 18, that is, it has to become 22 dB. So just find, okay, is 20 log of 12.5 is 22 dB? It is. Just find out. 20 log of 12.5, is it not 22? Is it?
Yes, sir.
It is.
Negative.
That's exactly.
22.
That's what is the other way of telling. Instead of reducing this 40 dB by another 18 dB, you reduce 100 by 0.125 times, that is 12.5. If it is 12.5, system is oscillatory. If you want to make the system to be stable, you have to reduce it below 12.5. Correct?
Yes, sir.
Okay. So, do you have any class in the afternoon? I don't know.